So this week we start to talk about geometry and geometric properties, and one of the most famous geometric properties would have to be the Pythagorean theorem, which states that if you have one of these triangles and it's a right triangle, which means that it has a little right angle right there, then this following relation is true. The fact that a squared plus b squared is always going to be equal to, and everyone knows it, c squared. But why does everyone know it? Everyone knows it because you were told so in high school, and most people aren't ever given a proof. So let's look at a proof. To do this proof, it's a geometric proof, we're going to look at two pictures, starting with this picture here. Notice in my example triangle, the short side is A, the long side is B, and the hypotenuse is C. We are going to follow that rule. So the short side here, we just have four identical triangles set up in a certain way. The short side here is going to be A, which means the short side here is A, and the short side here is A, and the short side here is A. And the long sides are all B. So we have B here, we have B here, we have a B here, and we have a B up here. So what does that mean for the area of this big box, the area of the whole thing? Well, this length here is A plus B. So we have A plus B, and if you notice, this length up here is also A plus B, because this is a big square. And it's called a square, so the way to find the area is you square one side, or you multiply the length times the width, the bottom times the side, and either way we get A plus B squared. But what if I wanted just the area of the triangles here? The area of the triangle right here, plus the area of the triangle right here, plus the area of the triangle right here. It would be the total area minus whatever the area inside of the box is. And what's the area inside of the box? Well, we know that each of these sides is a C. C here, C here, C here, and C here. And what's the area of a box with four sides that are all C? It's just C times C, or C squared. So the area of just the triangles would be this total area, A plus B squared, minus C squared. And does that prove the Pythagorean theorem? Well, not exactly. So we need another picture. We're going to set these triangles up in a different way. We still have the same four triangles, but this time we set them up in little rectangles. We set them up as two rectangles. Notice we have the same triangles. And how are we going to complete this proof? Well, the same exact way. We're going to build this box exactly how we built that box. So now we have the big square. And what is the square made up of? Well, the long side is all B. The long side is B here. And then we have the short side here is A, which means the short side here is A, short side A, short side A, long side B, another long side B. Try to move this over a little bit, maybe zoom out. And a short side A. So what's our total area? Well, we have A plus B on the bottom, and we have A plus B on the side again, so our total area, once again, is going to be A plus B squared. So these two boxes have the same exact total area. But what if once again I wanted the area of the triangles? I just want the area of these triangles, because I want to be able to compare my two equations in the end. Well, the area of the triangles are going to be this total area down here minus whatever this area is plus whatever this area is. We're going to be subtracting these two out. And what do we get? Well, the area up here is B times B, which is B squared. So we're going to be subtracting out a B squared. And the area down here is A times A, which is going to give us an A squared. So we have A plus B squared minus B squared minus A squared. And that's our area of the shaded in section, the area of the four triangles. And over here, that same area is A plus B squared minus C squared. So if we have two things that are the same exact area, we can set them equal to each other in an equation. So we get A plus B squared minus C squared. I'm going to have to scroll out a little bit more here. That's going to be equal to A plus B squared minus b squared minus a squared. A squared. And so we have this big long equation, but you right away notice that we have a common term. We have a plus b squared and a plus b squared over here. And when you have one thing on both sides of an equation, you can subtract both sides by that thing. So we lose that and we lose that, and we end up with negative c squared is equal to b squared minus a squared. Negative b squared minus a squared. Multiplying by negative 1, we have c squared is equal to negative b squared times negative 1 is going to be b squared, and negative a times negative 1 is going to be plus a squared. And we recover the Pythagorean theorem, a squared plus b squared is equal to c squared.